my algebra class is going to get the homework done for 8.5. It says in exercise 1 through 4, find the x-intercept and axis of symmetry of the graph of the function. Okay, so when we're finding the x-intercept and axis of symmetry, let's remember that new formula that they gave us. We know that we're crossing our x-axis. If this is 0 here, this has to be -3. This has to be 1. So we're going to take them and add them together and then divide them by 2. Right? -3, +1. Those are our x-intercepts. We're going to add them together. That gives us -2. And then divide them by 2. That's going to give us -1. So our axis of symmetry is going to be -1. Okay? All right, let's go to number 3. Number 3, we know that our x-intercepts are going to be -7 and +5. So we'll add those together, -7 and +5. We'll add those together. That'll give us -2, and -2 divided by 2 is -1. So the axis of symmetry for this graph will be -1. All right, oops, sorry. This one, it says, in exercise 5 through 10, graph the quadratic function. Label the vertex, okay, the axis of symmetry, the x-intercepts, and find the domain or range of the function. Wow, okay. So first things first, we're graphing this. If we do this, we know the x is going to go through -4 and -1. Our axis of symmetry can be found by taking -4 and -1, putting them together. That's going to get us -5, and we'll divide it by 2. That's going to be -5/2, which is about -2.5. All right. So there's -4, -1. We add them together and get a -5/2, just like I said. Now we know our axis of symmetry. Now we're going to plug this axis of symmetry back into the formula for x, and that's going to let us know where the vertex is. All right, so we're going to take -5/2 and replace it with x, or we're going to place x with -5/2. Sorry, other way around. A -5/2 plus 4 is 3/2, and -5/2 plus 1 is -3/2. When we multiply these together, we get -9/4. Now that we have -9/4, we know what our vertex is. We take our axis of symmetry, -5/2, and put it for x, and we take -9/4 and replace it for our y value. Now we come down to our graph. We know -5/2 is like -2.5. So if this graph is going by, let's see, this is 6. So this would have to be 1, 2, 3, 4, 5, 6. Good. So that's -2.5, 1, 2.5, right? And then -9/4, well, that's like -2 1/4. So we go down 1. This looks like it's going down by 2s because this is a 4 here. So 2, and then just a little past it, 1/4. All right. Let's go ahead and do number 7 now. We're going to work number 7 out over here just so we get one of them that we're working out very slowly with you in case we still have people having problems. First, let's go ahead and find that vertex. We already know that this is going to be, I'm going to move this over here. There we go. So we got number 7 here. We know that we have x plus 6 will equal 0. And we'll have x minus 4 will equal 0. And so when we work these out, just in case people are forgetting how we got this, x-intercepts. One x-intercept is going to be -6, right? And the other one is going to be a +4. All right, now we're plugging that into our problem, or our formula. -6 plus 4 divided by 2. Well, -6 plus 4 equals -2. negative 2 divided by 2 equals negative 1. And now we know what to plug in for our, that's our x-intercept, okay, x-intercept, or x value for our vertex. Now we're going to come over here and plug this in. So now we're going to have, let's see, we're going to have negative, and then we're going to have what negative 1 is replaced for x, plus 6. And we're going to have negative 1 minus 4. As you can see, negative 1 plus 6 is 5, because 5 minus 1 is 6 minus 1 is 5. And then negative 4 times negative, or plus a negative 1 is negative 5. Now we have 5 times negative 5, that's going to be negative 25. And negative 25 times a negative is going to be a positive 25. That is going to equal our y. So now we have our vertex. The vertex is we're going to have negative 1 and 25. So on our graph, we're just going to pop this up and see how I did. There we go. We see that we had, we took negative 6 plus 4, just like I said over here, divided by 2, that gave us a negative 1. That's our x value for our vertex. We plugged in negative 1 and got 25. That's our y-intercept, right? So now we have our vertex. We'll go to negative 1 on our graph and up to 25. And then we know that we're crossing through negative 6 and 0. So we'll put 1 here and 1 here and then make our arc. Okay? Let's go ahead and get to, see, number 8 or number 9. All right, number 9, I'm not going to write this one out because I did it last time. Again, we know our x-intercepts are going to be negative 1 and negative 2. When we add them together, we get negative 3. And then we divide by 2, we get negative 3 over 2. We're going to plug negative 3 over 2 into our problem. Negative 3 over 2 plus 1 is negative 1/2. Negative 3 over 2 plus 2 is 1/2. Negative 1/2 times 1/2 times 5 is negative 5 over 4. That makes sense because this is going to be negative 1 over 4, and then times 5 will be negative 5 over 4. So now we have a vertex, and we just go ahead and make our graph. All right. Oh, I want to ask for domain and range. I think I forgot that on the last one. On this one, the domain was all real numbers. So if we go back and correct that. Domain was all real numbers, and then the range, of course, is it has to be greater than negative, greater than negative 9 over 4. Over here, the domain was all real numbers, but it had to be less than, right? Less than 25. All right. Sorry, I had to go back and remember all the things I'm supposed to include in my answer. So on number 9, once we got our answer, we're going to plug that in. Remember, domain is all real numbers, and y has to be greater than negative 5 over 4. All right. Let's go ahead and get to number 11. All right. For number 11, we have to work this out. We're going to have to, we see that we have a negative number and a number, that number is, I can get the square root of it, right? So in case people forgot, this can be turned to, let's see, I'm going to work it over here, x2 minus 9 is the same as x squared minus 3 squared, which is going to give us x minus 3, x plus 3, right? And that, of course, is going to give us x equals 3. X will also equal negative 3. Now I can plug this into my formula, right? Because I've got, that's going to give me, all right? You see over here, x plus 3, x negative 3. So we know that our, we've got one going through 3 and one going through negative 3, right? That's our negative 3 plus 3 is 0. And 0 divided by 2 will give us 0, all right? And now that I know that that's 0, we put this back in our formula, right? Just as it is, x squared to the 0 power, right? So that's 0, I mean, x squared, 0 to the second power is 0, and 0 minus 9 is 9. And that means our vertex is 0, right? That's our x value for our vertex. And then negative 9 is our y value. So we'll go down to negative 9. It's going to be right there on our y-axis. All right? Let's go ahead and work this next one out. Right here, we see that we're going to factor out negative 5 from both of these. When we do that, we're going to have, actually, we're going to take negative 5, let's see, negative 5x, right? That's just going to leave us x plus 1, or negative 1, x minus 1, right? So right here, we factor out negative 5x. That leaves us with x minus 1. That's what we just said. So now we're just worried about x minus 1, right? And negative 5x. And in case people forgot, because I know people might be thinking, where did the 0 come from? Remember, we put all of this, negative 5x is equal to 0. Right? And that means I'll divide negative 5 away. And that means x is going to equal 0. Okay? And then we also have x minus 1 equals 0, which means this is going to be x equals 1, right? And that's what we have here. So we take 0 and 1, add them together here. That's going to give us 1, and 1 over 2 is 1/2. We're going to replace 1/2 in our problem, okay? So now we have 1/2 squared, that's 1/4. And now when we take 5 times 1/2, that gives us 5 over 2. A negative 5 times 1/4 would be negative 5 over 4. And negative 5 over 4 plus 5 over 2 is 5 over 4. Now that we have that, we have our x value and our y value for our vertex. And we just make our graph. I'm not sure I remember over here, domain was all real numbers, and the range is y is greater than negative 9 over here. Of course, with this parabola going in this direction, we have all real numbers, and the range is y is less than 5 over 4. Less than 5 over 4. All right, let's go to number 14, or no, number 15, sorry. All right, number 15, let's see here. On this one, we're going to have to solve it. Okay, so we're looking for factors of 14, positive 14. Well, that's 1 and 14. That's also 2 and 7, right? And because this is a positive number, these have to be positive numbers, right? So now we know that this one's going to be x plus 2 and x plus 7. All right, now that we have those, we know that x is going to equal negative 2 and x is going to equal negative 7. We're going to take negative 2 plus negative 7 divided by 2. That's going to give us a negative 9 over 2. And now we plug negative 9 over 2 into our formula. That's going to give us negative 9 over 2 squared plus 9 times negative 9 over 2. And then plus 14. All right, well, negative 9 squared is negative 81. I'm sorry, positive 81. Negative times a negative is a positive over 4. And we're going to have over here, well, this is going to be a negative 81 over 2. And this is a, yeah, negative. And then this is a plus 14. Well, we know that we can get the same denominator by multiplying this by 2 over 2. So now we're going to have positive 81 over 4 minus, let's see, 81 times 2 is 162 plus 4, or 14. Well, negative 162 over 4 plus 81 is negative 81 over 4 plus 14. Now I have to say, well, how much is 81 over 4? Remember, every fraction is a division problem, so this is really 81 over 4, right? And 4 goes into 8 2 times. And then we don't have any value here as we're about to approach our decimals. We'll put a 2 over here. Let's see. And then we can put another one here and make it this a 5. All right. So this is really 20.25. So now we have negative 20.25 plus 14. Okay, remember, my signs are different. I find the difference. So this is going to be 25. Our decimal goes here. This would be a 6. And because our bigger number is negative, this would be a negative 6.25. All right, so our vertex should be at negative 9 over 2. And negative, well, I guess I could have turned this into fraction. What's negative 9 over 2? That's really negative 6.25. I can turn these both into decimal form because negative 9 over 2 is negative 4.5. And now we have negative 6.25 as my y value for my vertex. All right, and the rest is making graphs. So let's go ahead and reveal our answer and see how I did. We got negative 9. We said that we're factoring this to x plus 7, x plus 2, just like I said. Then that means that x intercept is negative 2 and negative 7. We combine them to make negative 9 over 2. That's what we did over here. We plug this in, and we got negative 25 over 4. Let's see, negative 25 over 4. I think that's where they went ahead and took the 12 or the 14. I'm just going to work that out so you can see where they got that from. 14, remember we'd have to multiply this to 4 over 4, right? So this would be, well, times, let's see, 14 times 4 over 4. Will give us, let's see, 14 times 4. That's a 6. Carry the 1, would be 56. So this would be 56 over 4, and you'd be subtracting, yeah, we would be combining 81, right? So we're taking 81 and minus 56. Let's see, this would be 81, negative 81 over 4 minus, or adding to, sorry, positive 56 over 4. And that's going to give us the 25 over 4, okay? Or the negative 25 over 4, sorry. Okay, and that's where they got that number there. Okay, and then they graphed it. And that was it. I did the long way on number 15 just to show you one more time how to factor out these things. Our domain is going to be all real numbers again. And then our range is going to be all numbers that are greater than negative 25 over 4. Negative, or greater than or equal to negative 25 over 4. All right, let's go to number 17. Number 17, well, we're going to factor out that 4 for sure, right? When we factor out the 4, we're going to have x squared minus 9x plus 8. We're going to find, we're going to factor them out. And since I didn't show that, I'll show that one part. Over here, I'm looking for numbers that make up an 8, right? And so that has to be a positive 8. So I know that 1 times 8 will do it. And a negative times a negative is a positive. But a negative 1 and negative 8 make negative 9. So that works perfectly right there because we needed a negative 9. So we're going to have 1 with x is minus 1, and then x minus 8, which of course gives me my x-intercept is x equals 1, x equals 8. And that's exactly what they got here. All right? 1 and 8. So then they put 1 plus 8 that gives you 9. 9 divided by 2, that's 9 over 2. We're going to plug that in. 9 over 2 to the second power is 81 over 4. Then we have 9 over 2 times 30, negative 36. That's going to give us a negative 162. We take 4 times, well, remember, this is 4 over 1. So we could factor that out, and that's just going to leave us 81. 162, negative 162 plus 81 is negative 81. Negative 81 plus 32 will be negative 49. And now we have our y value for our vertex. We plug that in. We see that the domain is all real numbers, and y has to be greater than negative 49. All right? Greater than or equal. Greater than or equal to negative 49. Let's move on. We got number 33. Use zeros to graph. We know the zeros are going to be x is negative 2 and x is 6. Okay? When we do this, we can go ahead and plot these in. Now we're going to go ahead and, so our plot is negative 2 and 0. And if you're wondering where they got the 0 from, remember, we're going to factor that into our problem and then solve it. Okay? Hold on. Sorry, I had to take care of something. Since I didn't show you how they did it, I'll show you real quick right here. Remember, they take this negative 2 and put it back into the problem. So now you have negative 2 plus 2, and you have negative 2 minus 6. Well, negative 2 plus 2 is 0. And now it doesn't matter what this comes out to, right? Because anything times 0 equals 0. And that's where they got the 0 from, all right? Now they went ahead and said, well, they've got f of x. They went ahead and take the, they factored out the x, okay? I'm sorry, I thought they were factoring it for a second. I had to double check because I thought I was wondering why they did it, but I realized they just have a strange way of showing foiling. So I'm going to show it the way we did in class, okay? Here, just take it right over here, and we've got x plus 2, and then we have x minus 6, right? We're just multiplying these, right? And that's going to give us negative 12 here. Then we've got negative 6x. We put a 0 here. And then we have, let's see, 2x, positive 2x, right? And then we have x squared, x times x. You remember doing this in class, right? So this is negative 12. This would be negative 4x. And this would be x squared. So that's a little recap of how they got from here to here. They used foiling. What they were saying was x times negative 6. That's what they did here. Okay. Then they said 2 times x, right? And then they also said they had to take 2 minus 6 because you're going to, and this is how I really don't like it, the way they do this. They're taking 2 and they're multiplying it to negative 6 to get the 12, okay? The 2x they're showing here is when they're going to have to combine these, and I think that's what they're kind of missing out in showing all this. So we got the x squared, x times x, then you got the x times negative 6, and you got the x times, or 2 times x. You have to combine these two together, right? Because you're going to get negative 6x plus 2x. And that's going to give you that negative 4x, okay? But over here, you can see how it works out very easily. And now that you have that, because you have a equals 1, and a is greater than 0, the graph opens up. We know that. Remember, there's nothing here, so since it's not a negative number, it's going to open upward. They're asking, see the function, okay. So because c is negative 12, we know it crosses through my y-intercept at negative 12. The y-intercept is negative 12, so we can plot 0 and 12 together, right? So let's see, we've got 0 and 12. Remember we said the, let's see, 0 and 12, we're going to pop in from, okay, right here. And then the numbers I got over here, negative 2, okay? And let's remember that from up here, negative 2. And then 6 right over here, positive 6, okay? And that's all they needed to go ahead and make this parabola. Now you could have said, well, where was the vertex? And we would say, well, we did find the axis of symmetry because you can take the formula. Let's see, we've got negative 2 and plus 6 divided by 2, right? And that's going to give us 4 over 2. And 4 over 2 is 2. So now you can see that the axis of symmetry was right here at 2. So now we have our, we'll take the 2, we could put it in there to go ahead and find our vertex, right? So we're going to take, well, x squared, right? So we've got x squared, we're going by this formula here, okay? So let's here, we could just put x is negative, or x is 2, so that's going to be 2 squared. And then we're going to minus 4 times 2, or yeah, we're going to take negative 4 and multiply it to 2. Sorry about that. All right, negative 4 multiplying it to 2. And then we're going to take, we're going to minus 12 from all that. When we do that, we'll have 4 minus 8 minus 12. Well, this is 4 minus 20, and that's going to be a negative 16. And as you can see right over here, 12, this would be negative 14, so this would be negative 16. That's where they made the vertex at 2 and negative 16. All right, a couple of things that they kind of left out there to fill in all the blanks, but yes, that's how they did 33. All right, let's go ahead and go to our next problem. Number 35. Once again, we're going to do the same thing. We're going to factor this out to get our answer. And again, I'll just show the stuff that they didn't do. They're looking for something that makes 18. Has to be two negative numbers because we've got a negative here. So we could say 1 and 18, but they're not going to make 11. We could say 9 and 2, and that does make 11, right? We also could have said 3 and 6, but that doesn't make 11 when we put them together. So this is the only one that makes negative 11. So we're going to go ahead and make one with x minus 9 and one with x minus 2. When we do this, this is going to give us x equals 9 and x equals 2. All right, so there we are right there with what we found, right over here. And now we know that we have x equals 2 and x equals 9 after we put them to 0 and factor them out, right? All right, so now that we've done that, we know that the zeros of the function are 2 and 9. That means they're going to pass through 2 and 9 on our x-intercept. Okay, and now we also know that it's going to go ahead and cross through, well, 18, right? So we know that the y-intercept, if this is 8, and this has to be, let's see, looks like it's going up by 4s. So this would be 12, and this would be 16. So this would have been 20. So this has to be about 18 here, okay? And yes, of course, if we really want to find the vertex, we know what to do. We're going to take our two numbers for x-intercept, right? 9 and 2. 9 plus 2 is going to equal 11. And divide it by 2, that's going to give us, well, we just leave it as 11 over 2. We know that that's equal to 5.5, right? And as you can see, my axis of symmetry is sitting right here at about 5.5. Because if this is 4, this must be 6, right? And 5.5 is sitting probably about here. And now we could simply take 5.5 and plug it in to get our vertex, right? Or our y-axis. So let's see, if I do it over here, I can just leave it as 11 over 2. So that would be 11 over 2 squared. And then we're going to take minus 11 times 11 over 2. And then we can add 18 to that. All right, and then this is going to give us 121 over 2. This is going to give us negative 121 over, oh, I'm sorry, this would be 4, not 2. This one would be 4. Let me change that out. Yes, because 2 squared would be 4. Now we're going to have to multiply this to 2 over 2 in order to get common denominators. So this is going to be 121 over 4 minus 241 or 242 over 4 plus 18. This is going to give us a negative 121 over 4 plus 18. We could take 18 and put it to 4 over 4. Or I could even take 121 and divide it by 4. So 121 divided by 4 is going to give us, well, that's going to give us 3 here. With the 1 left over, I have to put a 0 there. Put a decimal here, and that's going to give us 2 for 8. That's going to leave us with a 2, and then we can put a 0 there and put a 5. So this is going to be, looks like 30.25. So now we have, where's my writing pencil? Oh, there it is. We have negative 30.25 plus 18. I have one is positive, one is negative. I take the big number minus the small number. So this will give me a 0.25 over here. And this would be a 2 and a 1 negative, right? Because we take the big number minus the small number to keep the sign of the big number. So now our vertex is going to be 5.5 for my x coordinate and negative 12.25 for my y. And so as you can see over here, like we said, if this is going up by 4s, 8, then this has to be 12. A little bit more than 12 is about right here. Okay. 12.25, and that's where they got it. And now you know how they got the problem. All right, that was all that I had to do. Remember, you had all the even ones to do. I'll see you in class for grading. Have a great night.